My name is Samuel Browning.
I'm Jack Coleman, and this is our final project for ECE 3710, the Microcontrollers class.
When we were thinking about project designs for the final project, we were really inspired by retro video games, especially ones like Pong and Tamagotchi, so we decided to make our own retro style video game.
I used to have an old handheld game that was kind of like a car driving between lanes on a freeway, dodging other cars, and so we decided we would go something like that.
In our proposal, we had a couple different criteria. Firstly, we were going to have two LCDs. One was going to display game messages, such as the score or the opening menu, and then the second LCD would display the gameplay itself. We were going to have four buttons controlling the player. Two buttons were going to move it up and down, and then two other buttons were going to move it forward and backwards. And then we were going to have a fifth button that would change game modes between an infinite game mode and a level game mode. And then lastly, we would have a buzzer that would sound at various points of the game.
Now, we were mostly successful with this, but that was the ideal, and we could not fully make it to that. We were only able to use one LCD because using two LCDs, we tested multiple ways, it just never worked out. We believe it was something to do with having, we needed multiple interrupts because of our buttons, and there just weren't enough pins to have the interrupts we needed for the buttons, a full LCD and another full LCD. And then as far as buttons go, we actually only ended up with 3 buttons in the final design. One button is still the game select button, but then the other 2 are just up and down for the car. Due to SysTick being overloaded, we were trying to have it do too much stuff. It wouldn't work out for us to move the car left and right. All right, so here's our final bare bones circuit. As usual, the microcontroller is connected to the computer with this link right here. Our LCD part of our circuit is powered by 5 volts. We have the incoming right there, and here's the ground. We have the LCD working on one breadboard, and then our buttons and buzzer working on another breadboard. The LCD is the exact same setup as it was in our LCD lab. All the pin configurations and everything are the same. We have a voltage divider that helps with the contrast on the screen. And then our 3 buttons down here and our buzzer are all commonly grounded and connected to the microcontroller. And we have a common ground coming between this breadboard to this breadboard and connecting to the microcontroller. Okay, starting up our game here, you see we've got a quick little loading screen that then will cut to our Welcome to Utah Driver Simulation message. And then it tells you are playing infinite mode. You can switch the modes of the game by pressing the red button, which Sam does here. Now it says he's playing level mode. And now to show you can switch back, he'll press it one more time, back in infinite mode, and now he'll press our green button to begin. And let's actually play this game. So the player car is the little greater than sign, and then the little boxes that are coming at you are the obstacle cars. And you can see that we can move up and down, and that the obstacle cars are coming at you at a relatively slow speed. Still pretty challenging. You gotta time that really good right there to get between those two. This is our infinite mode, which will have varying speeds depending on how many cars he passes. So he won't play forever in this one, he'll let himself die right here. And then you get to hear the sad game over sound, and it'll show you your score based off how many cars you passed. Now we'll go back to the menu, and it'll switch to level mode. He'll press green again to begin. Now in level mode, the rules are if you pass 20 cars, you pass the level. So I've sped up the video here just for the sake of time, so Sam can pass 20 cars real quickly. Also, right here you can see how we never have more than 3 obstacle cars on the screen at one time due to timing. And you can also see how they come at somewhat random intervals so that the gameplay doesn't get too repetitive. And then right about here, he'll end up passing 20 cars, and then, woo, we get a much better sound because it's a positive note. So it'll say level pass and then send you back to the menu again. And now just to show that the level mode works the same as the infinite mode, if you die, here Sam will only go past a couple cars, and then he'll let one hit him, and the detect collision will return true, and it'll end the game and tell him his score. And those are the different ways that the game works.
This is the final state of our code for our final project. At the beginning here, We declare all of our global variables. We have 3 variables to determine the position of the 3 cars. We have a global score variable, as well as one that keeps track of what line the player is on, and then 2 variables to select and play the different game modes. In our SysTick handler here, we only go into this if it's in game mode 1 or 2, and depending on if it's an infinite game mode or level game mode, they will both scroll through and detect for collision, but the level game mode will also additionally check to see if the score limit has been reached. These 3 here are button interrupts with our debouncing logic. The blue button will set the player line to 0, the green button will set the player line to 1, and then also set the game mode to what the game mode select variable is. And then the red button will increment the game mode select variable, sound a buzzer, and then also make sure the game mode select variable is either 1 or 2. In our main function, we go through several initializations for the LCD and the random number generator, and then we set all of our GPIO modes, and then set up all of our interrupts for our buttons. We also enable our buzzer, and then initialize SysTick using the load variable from earlier. In our main function, we have the loading screen in the main menu here, and then we go into an infinite while loop with 5 different states in a state machine. The first state is the opening menu, where it will declare what game mode you are about to play and then tell you press green to begin. In the case 1, the second case, it will go into the infinite game mode, and it has a variable speed for different score levels in the infinite game mode. Case 2 is for the static speed of the level game mode, and then case 3 is our game over screen, where it will also display your score and sound a buzzer. And case 4 is the screen to tell you that you have passed the level and play another buzzer as well. Here in our custom functions, we have a print car function. It has empty strings full of space characters. Then certain positions based off the car position variables are overwritten with the box character. And then depending on what line the player is in, it overwrites the 0th position with the caret. Then it clears the screen and then displays each of those strings on both lines. The scroll car function will first call the print car function previously, and then decrement the position of all the cars. And then they will check to see if the cars are off the screen. If they are, they will reset them to the end of the screen plus a random value between 0 and 4. The detect collision function will check for each car to see if it is in the same line as the car, and if it is, it will set the game mode to be the same as the state machine for the game over screen. Similarly, the check end level function will check to see if the score has reached greater than or equal to 20 cars passed. If it has, it will set the state machine to 4 and clear the screen. Our sound buzzer function has 3 double nested for loops that will play 3 different frequencies on the buzzer back to back to back. And then down here is our SysTick initialize function, which is the same as that from the stopwatch lab. While testing our project, we ran into a couple of bugs and quirks, most of which we were able to fix. The only one we were not able to fix, however, was something we have deemed Ghost Car.
Yes, Ghost Car has become an infamous thing that we have to deal with, because there is a 4th obstacle car that will show up sometimes on the LCD. It'll pop up at weird places on the LCD, show up for a second, and then go away. Now, it doesn't change gameplay at all, because if this actually collides with our car, it doesn't bump into the detect collision mode, and so it doesn't end the game. We have not been able to find the root of this problem in the time that we were allowed, so for right now in this game, this is just a fun quirk that we have, or bug, and that is Ghost Car. Okay, so if we were to do this project again, obviously we'd want to make a couple of differences just so that we could be closer to our actual proposal project. Like this, we would want to do 2 LCDs, or possibly a different LCD than the one we got in our lab kit, just so we could have a more functional LCD mechanism. We could also have a different timer or different implementation of SysTick that would allow us to have more obstacle cars coming on the screen at a faster rate, and include that bounce back ability of the player car.
Overall though, we are happy with how our project turned out. It's still a fully playable game with multiple features, and even though we didn't meet all of our design criteria, it still works at the end of the day. Thank you for watching.